let's solve this integral. But before that, let me show you a shortcut formula. If you have the integration dx by x square minus a square, that is equals to 1 by 2a ln x minus a by x plus a plus c. And similarly, if you have the integration dx a square minus x square equals to 1 by 2a ln ax plus minus plus c. Here, yes, you can take minus common and it will be the same as that with minus, but using log properties, these two will be the same. Now on to this integral. Let's see how we can solve this. Let's first look at what kind of looks weird. Here, sin x, okay, tan x, okay, but sec x, cosec x, that looks a little difficult to deal with. So, you know what, let's just remove them for simplicity. So, sec x is just 1 by cos x, and cosec x is just 1 by sin x. So we have sin x for tan x minus 1 by sin x cos x whole by sin x dx. Now this we multiply with that, so we get sin x dx for tan x sin x cos x by sin x cos x. Now here, tan x is simply sin x by cos x, so the 1 by cos x and cos x will cancel, so we'll have sin x, and this will go above here. This will multiply out to be sin square x cos x, and here we will have 4 sin x into sin x, which is just 4 sin square x. Sorry, there should be a minus 1 here. So we'll have a minus 1 remaining like that, dx. Now, let's see what we can do next. If we're talking about integration, we should also think about derivatives in the steps we are confused in. So, what's the derivative of sin x? Aha, cos x. So, let's just simply let u equals to sin x, so that du equals to cos x dx. So here we have u square du, this part is du, for u minus 1. Now this, for u square. Now this looks a bit difficult to deal with. Kind of. It is actually quite simple. You have to make the coefficients same. For u square du, for u square minus 1. And then after that, we try to make the numerator and denominator same. So we have 4u square minus 1, 4u square minus 1. But we cannot do that since it changes the question. So what we will do is we do minus 1 and plus 1. So this part is 0 and we haven't changed the equation. Now we have 1 by 4. We can separate these into two separate fractions. So we have 4u square minus 1 by 4u square minus 1, which is 1, plus 1 by 4u square minus 1 whole dx. Now let's just separate this into different integrals. So we have 1 by 4 dx plus integration of 1 by 4u square is just 2u square minus 1 square dx. So that's why I have showed you guys this shortcut formula. We have x square minus a square, where we have 2u square minus 1 square. So let's just apply it here. 1 by 4 dx, that's simply x, plus, there should be du here and du here. This is not x, this is u, plus integration of this. Using that, we have 1 by 2 into 1. But here you should have another trick here. So in here we have 1 by 2 into a, which is here 1, but there is a coefficient in the u. Let's go to the formula. If in the formula we have a coefficient, let's say m, then this will be 1 by 2a, but here we have to multiply by m here. So we multiply here by 2 ln 2u plus minus 1 2u plus 1 Now let's just multiply with 1 by 4, u by 4, but we know u is sine x, so this will be sine x by 4 plus 1 by 4 into 4, 1 by 16 ln of 2 sine x minus 1, 2 sine x plus 1 plus c. Let's solve another integral, but before this I will show you 3 shortcut formulas again. So for this integral, the answer will be ln x plus root x square plus a square plus c. For this, it is quite similar. It is x plus root x square minus a square plus c. For this, it is ln. No, it is not. It is in fact sine inverse x by a. You can use a short trick. For x square minus a square, you change the sign, so you use the sine. So here, a little note. The integral of this is 1 by a tan inverse x by a plus c. So now in this question, what shall we do? We have cos x minus sin x dx by root sine 2x. So for sine 2x, if we use the multiple angle, we have 2 sin x cos x, but that doesn't seem to do anything. So what shall we do? Let's do what we did in this integral right about this step, the minus 1 plus 1 step. Here, the plus 1 minus 1 step. Cos x minus sin x. But where should we use the minus 1 plus 1? Here? Well, that doesn't seem to do anything because 1 plus cos x, 1 minus sin x. You have to go to some multiple angles, but that seems very lengthy. So let's apply it here. 1 plus sine 2x minus 1. So we don't change the equation. Now, what is 1 plus sine 2x? Well, let's see. If you open sine 2x, we have 1 plus 2 sine x cos x. And here, 1. We have a very, very well-known equation as sine square x plus cos square x equals to 1. So here, instead of 1, we can just write sine square x and cos square x. So, and the remaining is 2 sine x cos x. Now what is this? Well, this is just a square plus 2 into a into b plus b square, which is a plus b whole square, on this case sin x plus cos x whole square. So instead of 1 plus sine 2x, we can write sin x plus cos x whole square. Cos x minus sin x root square minus 1. Now, again, when we think of integrals, think of derivative. Now, let's see sin x plus cos x derivative because it is under the whole square form. So, let's use the derivative of sin x plus cos x. Let u equals to sin x plus cos x, whose derivative will be cos x minus sin x dx. Wait, that is the same as numerator. So, it simplifies down to just du root u square minus 1. Well, 1 can be written as 1 square. Which one does this correlate to? It relates to this one. So, it is ln u plus root over u square minus 1 plus c. But wait, we have to convert u back. So, we have ln sin x plus cos x plus, well, if you again do sin x plus cos x whole square minus 1, well, you get this, then you go back here, and then you ultimately go back to sin 2x plus c.